Hello, the topic of our today's speech is analysis of student activity on e-learning course based on OpenEdu platform logs. We will tell you about the solution that is made by our team. Nowadays, we are facing such a phenomenon as constant sharp increase in the number of online platforms for students. But the number of teachers remains stable, which means that the load for professors and lecturers rises. Control of student studies is one of the important components in the whole educational system, but implementing such severe tasks can be made only by using different analytical tools on online education platform. Teachers should track student experience in order to understand pros and cons of whole online experience and, if needed, correct some information on educational platform. Tracking experience include academic performance and user activity. Online electronic educational learning platforms are very popular nowadays. One of the biggest and widely used platforms is OpenEdX. This is an open source software platform that provides off-the-shelf tools for educational services. One of the important features of the platform is that it generates student and teacher activity log files. But the disadvantage of the platform is that it doesn't provide any data analytics tools for monitoring educational progress and success. The most popular educational platform in our region is Open Education, which is implemented using OpenEDX platform. The problem of OpenEDX platform, in a particular of one of its implementation, Open Education, is that built-in analytical tools experience lack of analytical functionalities.
Severity of this problem is determined by the fact that teachers conducting courses on a platform are missing the tool for analyzing the learning experience, which leads us to missing control on the educational process and decreasing its efficiency. So, on the other hand, the students who use the platform are also not able to monitor their academic performance. So, that's why it's important to provide teachers, course administrators, and students with educational analytics tools that help them to make the educational process more efficient. Improving online educational platforms can make online learning at universities more friendly, easy, and productive for all the involved people.
The main goal of our project is to provide an opportunity to analyze the logs of the Open Education platform by creating a software and analytical tools that implements the loading, storage, processing, and display of analysis results. To achieve this goal, it was necessary to solve the following tasks: explore the structure and format of the logs provided by the Open Education, expand the test bench with the API platform for collecting test data, implementing software interaction, and conducting experiments. To propose a software structure for software tools that allows to analyze logs, and the last one, implement a software tool that will be convenient for the end user.
To obtain user-friendly software implementation, we had made a set of requirements. The software solution should be able to process logs of semi-structured format, provide user with a list of logs from the database available for analysis, retrieve and show the result of running an analytics tasks, download analytic results in CSV, TXT, and HTML formats, and have user-friendly interface.
To make high-quality software product, we made some requirements for ready analytical tool. Our system should prevent data losing after service restarting, execute any analytic task in more than 1 minute, and be fast integrated into customer's company business process with minimal expenses for any company. And of course, we need to follow security rules and prevent data leaks while working with customers' data.
Let's talk about our refined project plan. As a development cycle, we have chosen Agile Scrum methodology with 1-week sprints. And our team consists of a faculty advisor as a supervisor, team lead as a backend developer, UI UX designer as a front-end developer, and DevOps as backend developer.
High-level architecture consists of three microservices. The first is UI service. It allows end user to interact with the application. The second is ETL service. It is responsible for receiving, transforming unstructured logs, and loading them into the database. And the third service is analytical service. It contains a set of analytical scripts working with the database and a model for building the analysis result files.
Now let's look at the more technical aspects of implementation of analytical tool. Our solution uses logs for making analysis. A log is an entry in a file or storage media. Whenever any activity is done on the main window on the learning management system, we record data and make an entry in a log file. Activity information can include different user activity, such as clicking on a link, watching or downloading a video, reading or downloading a PDF or PPT file, and of course submit test answers.
Activity types of the logs can be divided into two groups. First, it's instructors activity types with such tasks as listing students, rescoring submissions, resetting attempts, getting students' progress, or adding, removing listing instructors. And the second group is student activity type with such actions as navigation in the online course, interaction with videos or other resources on the e-learning platform, and submission of tests or homeworks.
Here you can see some analytical task which was implemented in utility. So we can calculate total user time on the course and user time distributed per day. We can calculate users who started the course but didn't finish it. We can show activity type for users on a course depending on the date. We can show the user way over the pages. We can calculate mapping for URLs and course section names. And we can calculate unique usernames and their IDs.
Let us take a look on one of analytical tasks. It calculates time users spent on course. This task is implemented as a script in analytical service. It takes logs from the database and uses this data for the further analysis. The input data of this task is student ID. The task searches for all records of events made by the student and calculates necessary metrics basing on this query result. The current task calculates the total time spent on the specific course by the chosen student. Finally, the analytical service provides the result of task execution in textual or graphical format.
As a result, software product gives different types of results, such as stack reports in TXT, CSV, visual graphs in PNG images, interactive graphs, HTML pages with graphs. Presenting results in different formats give variability for the end user. The hint map, which you can see on the slide, represents the time which students spent on the course. On the horizontal axis is a date when student was active on the course. On the vertical axis you can see the name of the course. The more time user is spending on a certain part of a course, the more intensive corresponding cell gets.
Here you can see different output formats such as XLS table or just plain text suitable for printing. The first one is the result of mapping of usernames according to their IDs. On the second image you can see the result of analysis of total time which users spent on the whole course. Welcome to the demo. So, our project is an independent project for analyzing logs that consist of the user actions from the educational project OpenEdu.ru. So, our front side provides a simple interface for interacting with our project. To create it, we choose one of the most popular frameworks, the React.js. So, let's look at the Logs tab. On the Logs tab, we can see all available logs on the server and all loaded logs on the database. We can clear our database and load one or several or all available logs on the server on our database. Let's look to the Analyzer tab. On this tab, we can see all the available tasks for analytics. These tasks can be applied to the logs in the database. Naturally, tasks may depend on what needs to be analyzed, and we made a convenient architecture for adding tasks on the backside. So let's run some tasks which could show us user way on the course. Here we are. During the competition, we agreed with our mentors a new design that will be better used by our end users. The first thing we did was a new sidebar. It's now look much better and has animation. The second thing is the Results tab. We came to the conclusion that we need to improve the Results tab. We now have a history of results. We can see here the last chart right on the tab, and also download it in the required format and of course in PNG. And of course a whole graph is interactive. Thank you for watching.
In conclusion, our ready solution has such options as downloading log files from educational platform, choosing log file between different courses on the platform, running analytical tasks based on downloaded logs, getting text or visual report about running analytical tasks. The first version of the utility already has released, and in future we are planning to update analytical tool by adding such technologies as Spark and HDFS, reducing the time of analysis processing. And last but certainly not the least, we want to run several pilot projects with students and teachers of our university.
Thank you for your attention.